Topic: Measurement and the SI system. Welcome, future toppers. This guide breaks down the core concept of physics, chapter 1, into simple bite-sized pieces, perfect for school exams and competitive giant like UPSC, SSC or NEET. Key concepts: measurement, comparing an unknown quantity to fixed standard. The unit, a unique name assigned to measure. Example, meter, second. Base quantity, independent building blocks, length, mass, time. Invariability, a standard must never change regardless of location or time. Definitions, clear and short. Physical quantity, anything you can measure. Example, how heavy or how long. SI system, the international system of units. Metric system, adopted in 1971. Derived units, units made by combining base units. Example, watt for power, scientific notation. Writing huge or tiny numbers using powers of 10. Important formulas and tables. Quantity, length, unit name, meter, symbol M. Quantity, time, unit name, second, symbol S. Quantity, mass, unit name, kilogram, symbol kg. Power derived unit, 1 watt is equal to 1 kg multiplied by meter square per second cube. Scientific notation examples. Big number like 356000000 meter is equal to 3.56 multiplied by 10 to the power 9 meter. Small number 0.000000492 second is equal to 4.92 multiplied by 10 to the power minus 7 seconds. Quick revision. Exam pointers. 1971. The year the SI system was finalized. Access. Standard must be accessible to scientists worldwide. Precision. The meter is defined by the speed of light for 100% accuracy. Computers. Tip. 3.56 multiplied by 10 to the power 9 is often written as 3.56 E9. Practice zone, multiple choice questions, MCQs. Which of these is not a base quantity? C. Power. When was the 14th General Conference on Weights and Measure held? 1971. E. In scientific notation. Example, 4.92 E minus 7 stands for C. Exponent of 10. A standard must be invariable so that it stays the same forever. What is the SI unit symbol for mass? C. kg. Short answer questions. Why is the arm length not a good standard? Answer, because it varies from person to person, not invariable. What is the benefit of scientific notation? It allows us to express very large or very small numbers easily using powers of 10. Fun fact, did you know light travels so fast that the meter is now defined by how far light moves in 1/299,792,458 of a second.